Hello dear students, today we are going to discuss the analysis of surface roughness and types of lay. What type of lay are there in surface roughness and what are the different methods to analyze the surface roughness. So first we will discuss analysis of surface finish. So generally we use three parameters for the measurement of surface finish. That is, first method is called as center line average method and it is represented by RA. Next one is root mean square value, that is RMS value. It is represented by RS. And the last is 10-point method and it is represented by RZ. So from where we will do the analysis of surface finish, what we have to do, we have to put the workpiece surface on the table. For example, like this. If this is the working table, then you have to put the workpiece here, and let us suppose the surface of the workpiece is like this. So you have to keep the stylus of the measuring instrument over the surface and move it in this direction. So you will get the profile of the surface according to the motion of this stylus, and you will get the graph like this. And after that, you can do the analysis part. After this process, you can do the analysis part. So first we will discuss the center line average method, that is the RA method. So in the center line average method, what we do, RA is average height from a mean line of ordinates of the surface regardless of sign. Let us consider after the motion of the stylus on the working surface, we get this graph. It is this graph. So what we have to do, we have to select a simple length. I have already told you the simple length which is to be tested, the length which is to be tested. So we have to draw the ordinates like on this graph, like y1, y2, y3 up to yn at equal distance. Now we have to measure the heights of these ordinates y1, y2, y3 and yn, and then according to center line average method, what we have to do, we have to do the summation of all the heights. We have to do the summation of all the heights like this, y1 plus y2 plus y3 plus up to yn, and we have to divide it by total number of ordinates. So in this way we will get the value of roughness by the center line average method, and we will get the roughness in microns. We will get the value in microns. We can also calculate the center line average method RA value by using the area. So in that case, what we have to do, we have to measure the area of each curve like this A1, A2, A3, A4, A5 with the help of planimeter. And after the measuring of area with the help of planimeter, we can measure the value of RA by doing the summation of all the values of area divided by the total length which is under the testing. It is the length of the specimen. So according to this method, CLA value can be given as the summation of all the area divided by the total length. So according to the BIS standard, that is Bureau of Indian Standard, the surface roughness is assessed in term of CLA value and is denoted by value RA. The symbol of center line average method is R8. Is it clear? Now the next method of measuring the surface roughness is root mean square value. root mean square value. What we have to do in root mean square value, we have to use these ordinates y1, y2, y3. In this root mean square value, what we have to do, we have to take the square root of the mean of the square of surface measured from the mean line, as y1, y2, y3 and yn are the height at equal space ordinates at the position 1, 2, 3, 4, 5, 6. I have shown in previous figure like this. And we have to do what? We have to square each coordinate, and then we have to do the summation and divide it by the total number of coordinate, and then we have to do the under root of that. So we will get the root mean square value, and the representation of the root mean square value by roughness is RS. It is represented by RS. Okay. So RS is what? RS is typically give the value of roughness greater than the CLA roughness 11%. 11% more than CLA value. So RMS value is more sensitive to peak and valleys than the center line average value, because we have squared each ordinate value. So it will give 11% result more than the CLA value by this RMS method. Now the next method is 10-point height method. In this method, what we have to do, we have to take the height of the valleys and roughness from a baseline, like in this figure, the average difference between the first highest peak and 5 lowest valleys of the surface is taken, and the roughness can be measured. So what we will do, this is the graph which we get from the movement of the stylus. Now what we do, we take 5 highest peaks and 5 lowest valleys, and we will do the summation in this way: 1 by 5 in bracket h1 plus h2 plus h3 plus h4 plus h5. This is the highest. These are the 5 highest peaks, minus h6 plus h7 plus h8 plus h9 plus h10. These are the lowest valleys, and in this way we will calculate the value of roughness with the help of using 10-point height method. And the roughness represented by RZ. If there is the value RZ is written, it means this is the value of roughness calculated by 10-point method. Okay, so in short we can say that RZ is more sensitive than RA to changes in surface finish, as maximum profile height and not average are being examined. Rmax is useful for surface when a single defect is not permissible, and RZ and Rmax are used together to monitor the variation of surface finish in a production process. Similar value of RZ and Rmax indicate a consistent surface finish, while a significant difference indicate a surface defect in an otherwise consistent surface. So this is how we will calculate the roughness by using the different methods: center line average method, root mean square value, and 10-point method. Now we will next we will discuss about the direction of lay. As I have already told you that the lay is the direction of predominant surface pattern ordinarily determined by the production method. Actually, it will tell you that in which direction machining take place. So this will show you the symbol, and this is the interpretation. So if there is a sign of equal to, then it means it is a parallel lay. It is a parallel lay which is parallel to the plane of projection of the view in which the symbol is used. So direction of lay, if this is a surface and this machining is done in this direction, this direction. So if there is a symbol like this, then you can easily tell that it is a parallel lay. This machining operation is done by a parallel process. For example, if we take the example of shaping, planing, so these are the machining operation in which we will move the tool parallel to the surface. So that shaping and planing is the example of parallel lay. Next is perpendicular lay. Perpendicular lay is the lay in which perpendicular to the plane of projection of the view in which symbol is used. Let us suppose this is the surface and the tool will move in this direction. So this is perpendicular to the tool will move perpendicular to the surface. So this type of lay is called as perpendicular lay, and this symbol indicates perpendicular lay. Next is cross lay. Cross in two slant direction relative to the plane of projection of the view in which the symbol is used. So if a tool is moved in a cross direction, then that type of lay is called as cross lay. For example, knurling process. In knurling process, the tool is like this. The tool will move like this and will give you the shape like this. So this is the example of cross lay. This is the example of cross lay. Next type of lay is multi-directional lay. Multi-directional lay means in which you cannot tell that in which direction machining takes place. For example, grinding, because there are number of minute particles which are present on the grinding wheel, and you cannot tell that in which direction that grinding wheel is cutting the material. So it is the example of multi-directional lay, and this is the symbol of multi-directional lay. Next, C represents circular lay, approximately circular relative to the center of the surface to which the symbol is applied. The symbol of circular lay is like this. For example, in facing process, when we do the facing on the lathe machine, you will get the structure on the workpiece like this if you will do the facing. So this is the example of circular lay. Next is radial lay, approximately radial relative to the center of the surface to which the symbol is applied. When you will do the radial milling, you will get the structure like this, and the symbol of the radial lay is like this, R. It is represented by letter R. So this is your radial lay. So these are the types of lay. First we will learn parallel lay, perpendicular lay, then multidirectional lay, radial lay, cross lay, and circular lay. Next is roughness grade and symbol. So the principal creation of surface roughness that is used by BIS is RA. Generally we use the center line average method to calculate the roughness. So there are number of grades of roughness according to BIS standard, and each grade is having the particular value of roughness. For example, N12. N12, the value of the roughness for the N12 is 50, and it is the symbol of the roughness is infinity. It is having the maximum roughness. N12 grade of roughness is having the maximum roughness. Then next is N11. It is up to 25 micro, and the symbol of roughness is inverted triangles, only one triangle. Next, 12.5. It also falls under the same roughness symbol, and it is represented by N10. Then 6.3, N9, and N9 to N7 represented by double inverted triangle or triangle. Next, 0.8 to point. Oh, sorry. Yes, 0.8 to 0.2. it is represented by 3 inverted triangles, and then point 1 to 0.025, n3 to n1, and it is represented by inverted 4 triangles. So these are the grades and symbols which are used by BIS to define the roughness. Next is, these are the values of roughness grade for the different machining operations. For example, sandblasting is a process in which we will get the roughness from 25 to 12.5 micron, and it will fall under the category of N12 to N10. So these are the different values. For hot rolling, it is also under the category of N11 to N10. So there are a number of operations in which value of roughness is defined according to the BIS standard for each particular operation. Next is how the surface roughness is represented. If there is a symbol, the symbol of roughness, I have already told you that it is a triangle. So what are the presentation of each symbol? What is the significance of each symbol which is present on this triangle symbol? So if you see this type of symbol anywhere in the drawing, you can easily identify that it is the symbol of roughness. Now, what is the meaning of this alphabet which is present on this roughness symbol? So very first is A, which is above this line. So A will give you the value of roughness. This A will represent the value of roughness. It is not A, it is some numerical value. It is the value of roughness, and it is represented by RA, and it is given in micron. Now at the corner point of the triangle, left corner point of the triangle, it is E. It is E. It will be the machining allowance. That is the allowance which is provided for the machining operation. Next, to the right of the corner of the triangle, it will give you the letter D, and D is used to represent the direction of lay. What type of lay it is? If there is a cross symbol, then it is cross lay. If there is C, then it is circular. So this D will tell you the symbol of lay. Next, the letter V, which is above this line, this V will tell you that what operation has been done over that surface which is to be tested, or whose roughness is being measured. So this will tell you the operation method or production method, treatment of coating, this B letter. Next, C. C or F. C will tell you the value of surface, sample length, the amount of the length which is taken for the testing process. So it will give you the sampling length, and in bracket, if any value is written with this C, then it will tell you the other roughness value. If other than RA value, center line average value है आपका, सेंटर लाइन वैल्यू से अगर कोई अदर वैल्यू है, फॉर एग्जांपल 10 पॉइंट मेथड से अगर आपकी रफनेस निकाली गई है, या रूट मीन स्क्वायर वैल्यू से रफनेस निकाली गई है, सो इट विल बी एट दिस पॉइंट in bracket. So this is how the surface roughness is represented by this symbol, and these are the significance of each letter A, B, C, D, E, F. So for today, my lecture is over. Thank you so much and have a nice day.